So today we're going to talk about combining like terms. So there are different parts of an expression that you need to know about first before you can combine like terms properly. So there are variable terms. So that is just a term with a variable attached. Remember, variables are those letters. So in this expression here, all of our variable terms would be the ones with the x attached to it. Now, make sure that when you're picking your variable terms that you're looking at the sign in front of the number as well. So it would be 7x, a negative 5x, and a positive 4x. So for our variable terms, we have 7x, negative 5x, and positive 4x. Now, along with variable terms, each variable term should have a coefficient. It's the number that's next to that variable. So the number that's in front of the variable. If there is no number there, it's a 1. So if you just had the variable x, your coefficient would be 1. If you had a negative x, your coefficient would be a negative 1. But for these three that we have here, our coefficients are 7, negative 5, and 4. Okay, so then there's also terms without variables, and those are called constant terms. Okay, so those ones are just the regular numbers. They do not have anything attached to them. And again, you want to make sure you're including that sign in front of that number when you're identifying your constant terms. So our constant terms here are a positive 3, a positive 8, and a negative 1. Okay, so when we combine like terms, you can simplify an algebraic expression by combining like terms, which that means just to combine the common variable terms and the constant terms. So if they share a variable, you can combine them. If they don't have a variable, you can combine them. You cannot combine numbers with variables and without them, or you cannot combine them if the variables are different. Okay, so for our example here, it's the same one from above. We've already classified them, and I think it helps personally to highlight like I did here, just to make sure that you have the numbers correct. You do not have to do that. That is a strategy that helps me keep everything organized, so I am going to continue that strategy. So I have my constants in green, and I have my variable terms in yellow. So now I can go ahead and combine my like terms. So I'm going to just add or subtract whatever my numbers are. So my x terms, I have 7x, I have negative 5x, and I have a positive 4x. Now, when you are combining these terms, you cannot add multiples of the variable. Okay, so the variable is just going to stay x, and we are just focusing on the coefficients. So we're doing 7 minus 5 plus 4. So 7 minus 5 is 2, and 2 plus 4 is 6. Okay, so I have 6x, and then I'm going to do the green ones, and that is a 3, an 8, and a minus 1. Okay, so 3 plus 8 is 11. 11 minus 1 is a positive 10. So my expression combined to its simplest form is 6x plus 10. So we're going to try a couple examples just to go through what that looks like and to show you what it would look like if there's more variables than just the one. So for example 1, I'm going to use my highlight tool again. I'm going to highlight all of my x terms, which is the only thing that's in this problem. So I know that I just have to keep my x and add the coefficients. So I'm doing 3 plus 6 to get 9x. Okay, so then for number 2, same thing, we're going to highlight to find our like terms, and we only have like terms here. We have 9a minus 10a, so I'm going to focus on 9 minus 10. The a stays, so 9 minus 10 is a negative 1a, which equals negative a. Okay, so for number 3, we have different terms this time. So we're going to go ahead and highlight again. So I'm going to highlight all my variable terms in yellow. This time I'll highlight my constants in pink. So I have 2 yellow terms and 1 pink term. So my pink term, my constant, is just going to stay the same. So I'm going to leave it as -6. And then I need to simplify my 7m minus 5m. So I'll leave the m and do 7 minus 5, and that gives me 2. So my answer here is 2m minus 6. All right, for number 4, we have 9 minus 6w plus 5. So again, I'm going to highlight. I'm going to highlight all my variable terms in yellow. Make sure you're including that sign in front of it. All my constant terms in pink this time. So I have 1 yellow term, so that stays the same. And then I have 9 plus 5, and 9 plus 5 is 14. All right, so I want you to pause the video and try 5 and 6, and then press play when you're ready. So for 5, you have your variable, variable, constant, constant. So I'm combining my 7 minus 9 to get a -2, and then -1 plus 5, and that gives me a 4. For number 6, and if you don't want to highlight, you can draw boxes around things too. You can do a box and an underline and an underline. Any way to organize this yourself. I like the highlighter personally, but whatever you want to do. I do recommend you use some method to make sure you're identifying all the terms and you're not putting more than you should. But continuing for number 6, we have 5h plus 7h, and that is 12h. And then we have -6 minus 8, which would be the -14. All right, so number 7, we are going to have more variables this time. So I want to make sure that I am not combining terms that are not the same variable. So I'm going to go ahead and highlight, and I'm going to pick all my x terms are going to be pink. And then all of my y terms will be the yellow. All right, so I have 5x minus x and a positive 3x. Remember, minus x is just like minus a 1x plus 3x. So 5 minus 1, that's 4, plus 3 is 7. So I have 7x. And then I have a 7y plus a 2y, and that's going to be 9y. And that's my simplified answer because I cannot combine that anymore. X's and y's are not the same variable, so I cannot combine that. So pause the video, try 8. If you're trying 8, you should have highlighted those or circled or identified however you did, and those. So I'm going to go ahead and combine my like terms, and my a terms, when I combine them, I get 22a. And when I combine my b terms, I get 12b. Okay, so we're going to go and try something different. So now we're going to have exponents. So terms with the same exponent or combination of variables and exponents are considered like terms. When you're combining them, you do not change the exponent. So when you are adding variables with exponents, you do not change the exponent. Okay, it's just a like term. You're only changing that coefficient. So for example, for number 9, I have 5x squared, and then I have another x squared term as well. So the x squared stays the same. I do not add that. It stays the same. It is just a like term. Just like it was just a regular x, now it's just got an exponent. It stays the same. So I'm doing 5 plus 7, and 5 plus 7 is 12. So my final answer is 12x squared. Again, we are not adding the exponents. For number 10, same idea. I'm going to go ahead and highlight. I have n to the 5th as one of my terms, and then n to the 5th is my other term as well. So n to the 5th stays the same, and I'm just adding the numbers in front. So -15 plus 4 is -11. Okay, so pause the video, try number 11. And for number 11, you should see that they are all the same term. C to the 3rd, so I leave C to the 3rd. And I'm just doing 8 minus 7 plus 16. 8 minus 7 is 1, plus 16 is 17. All right, so for number 12, we're going to highlight our terms. So I'm going to keep x squared terms or k squared terms, sorry, as yellow. I'm going to use k terms as green, and make sure you're keeping that sign in front. And then I'm going to use constant terms. We'll do purple this time. Okay, so I have 3 different colors now. I have 1 purple term, so I can just leave that as is. And then I have to combine my other 2. Now, when you're writing these out, you need to make sure that you are keeping your expression in order, alphabetically, and through the highest powers. So if you had an A and a B term, you want to make sure that the A terms are written first, because alphabetically A comes first. Now, if you had A squared and A, you'd want A squared to come first, because A squared has a higher power or a higher exponent than A does. So in this example, we have a K squared and a K. So since K squared has a higher exponent, we're going to make sure we keep our K squared terms first and then our K terms second. So we're going to focus on our K squareds. So we have 8K squared minus 2K squared. So 8 minus 2 is 6. So I'm going to write 6, bring down the K squared. And then I have a negative K, or that's, remember, minus 1, minus 5. So negative 1 minus 5 is a negative 6. Bring down the K. Okay? So make sure when you're writing it, you keep it in alphabetical order, and the higher powers come first. So for number 13, you only have, yes, you have 2 variables now in one of your expressions. However, they're the exact same, a squared b and a squared b. So those are like terms. And then we have plus 7. So our plus 7 is going to be the same. There's only one of it. There's only one yellow. But then I have 2 purple terms. So I have the minus 4, or negative 4, plus 10. So negative 4 plus 10 is 6. So I'm going to write down the 6, and then I just bring down a squared b. Because I do not add those together. I just keep that term the way it is. All right. So for number 14, this one has multiple variables. So the organization is going to be a little trickier. So I'm going to go ahead and first start by identifying all of my like terms. So I have an x squared term. I have an xy term. I have another xy term. And I have a y squared term. So alphabetically, x comes before y. So I now want to keep my x terms first. And then I have an x squared and an x. So the x squared needs to be first, because that 2 is a higher exponent than the 1 for the xy terms. Okay, so it would be x squared terms, and then our xy terms, and then our y squared terms. So we're going to start our x squared. We only have 1, so I'm just going to write that down. And then I have a 2 minus 7. 2 minus 7 is a negative 5. Bring down the xy. And then plus 4y squared, because there's no other pink term. All right, so pause the video. I want you to try 15 and 16. For 15, we have an a squared term. We have an ab term, an ab term, and we have a b squared term. So I'm going to go ahead and simplify that. My a squared stays the same. AB term comes next alphabetically. So I have 7 minus 10, and that's a negative 3. And then my b squared is the only one there, so I write that down. So 15, you should have had a squared minus 3ab plus b squared. For 16, we're going to identify all my terms. So let's start with x squareds. There's that x squared. There's this x squared. And now we're going to go ahead and identify our constants. We have a negative 7. Those are x terms, negative 6. And then I'm going to identify my x terms, which are these. So now I have multiple colors. Remember, x squared comes before the x term because the exponent is higher. So we're going to combine our x squareds first. So we have 4x squared minus 3x squared. 4 minus 3 is 1. So I can just write that as x squared. And then I have next would be the pink terms, the x's. So I have plus 2x and plus 8x. So 2 plus 8 is 10. And then I have my yellow terms, negative 7 and negative 6. So negative 7 minus 6 is negative 13. Right, so geometric applications. Give the perimeter of each figure as a simplified expression. So remember, the perimeter of a figure is when you are adding up all of the sides. So all you're doing is adding up all of these numbers and then writing it as a simplified expression. So I'm going to go ahead and you can rewrite this. So I'm going to rewrite it as I have 2x plus 1 plus x plus 3x. Okay, and then I can go ahead and highlight. So I have my x term here, an x term here, and an x term here. And then I have a constant term. So I'm going to go ahead and do my 2 plus 1 plus 3. 2 plus 1 is 3. 3 plus 3 is 6. And then plus 1. Okay, so my final answer here is 6x plus 1. Try 18. All right, so if you've tried 18, you should have first rewritten it. Right, and then I'm going to go ahead and highlight. So I have a constant term and another constant term. I have an A term and another A term. And I have an AB term. So my A term is going to come before my AB term because A alphabetically comes before the A and the B. So we're going to go ahead and start with our A terms. So I have a negative 1A plus 5A. So negative 1 plus 5, that's 4. And then I have my AB term next, and there's only one of them, so I'm just going to keep it. And then I have 17 minus 1, which is 16. All right, so for number 19, they give us two sides, but as you should know in a rectangle, this side is the same as this, they're congruent, and this side here is congruent to this side. So I have y plus 2 and 3y minus 5 here. So when I'm writing this, I have 3y minus 5 plus y plus 2 plus 3y minus 5 plus y plus 2. Okay, so I'm going to go ahead and highlight all of my y terms. So I have y term, a y term, a y term, and a y term. And then I'm going to highlight all of my constants, constant, 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 constant. And then I can go ahead and combine. So I have 3 plus 1 plus 3 plus 1. That's 8. Then I have a negative 5 plus 2, minus 5 again, plus 2. So negative 5 plus 2 is a negative 3. Minus 5 is negative 8. Plus 2 is negative 6. And that would be my final answer there. Right, and then for 20, you've got to combine all of those terms. So I'm going to start on this side. I've got k squared plus k plus, at the top, k squared minus 9k plus 23. Maybe, there we go. Plus, well, it looks like a b. Let me fix that. 23 plus k squared plus k plus 2k squared minus 17. All right, so there's a lot of terms here. So we're going to highlight. I'm going to do all my k squareds in yellow. K squared, k squared, k squared, k squared. And then I'm going to do my k terms in pink. K, k, k. And then my constants I'll do in purple. So now I'm going to go ahead and start by combining my k squareds. So I have 1k squared plus 1k squared plus 1k squared plus 2k squared. 1 plus 1 plus 1 is 3 plus 2 is 5. Okay, and then we're going to do our k terms. We have a 1k minus 9k plus k. So 1 minus 9 is negative 8 plus 1 is negative 7. And then I have 23 minus 17, which is 6. All right, so what you're going to do now is you're going to go ahead and practice these in the Go formative. One thing about the Go formative that I want you to know is how to type in some answers. So when you are on the Go formative, which I'm going to bring in front of you right now, okay, when you want to type in exponents, so say for example in number, let's just pretend there's an exponent number 1. Okay, if you want to type in an exponent, there's two ways you can do it. You can press on this keyboard and there is a squared button here. This will give you x, just the exponent of the 2. Or if you have a variable like, let's just do x, and you want a different exponent, you can pick this button right here, and then you can type in your own exponent. Or you can press the caret button on your keyboard, which will let you go ahead and just input whatever you want. It is on my keyboard connected to the 6. I'm not sure why it's not working right now on my screen, but it's connected to the 6. You just press whatever variable you want, Shift 6, and then there you go. And then there's your variable, or there's your exponent. Okay, so it will just make it like that for you. If you want to go back down, because you can see my cursor, it's still up here with the exponent, you would just keep pressing to the right, and it'll go back down to normal size. Okay, so you can either use this button, or Shift 6 on your keyboard to get to your caret key.